we go. Okay, now we're broadcasting. So we got cut off. I don't know what happened. I'm very technically challenged with computers.
No, you're not.
Oh my gosh. So this is group 10 lesson. We're going to continue. We're in the middle of the quiz, and I will post both of these. So anyway, we were on question 7. Is that where you're at still, or did you go ahead?
Yeah, well, I worked out question 7. I was working on 8. You were doing 7, and then I went back to 7, and then I kind of went on to the next couple. But
Yeah.
we'll go back to 7 here.
Oh my gosh.
So 7, did you get 498.1 or 0.315?
I did, yeah. And the other one I figured out, yeah. 5, so it's 526
okay,
plus
yeah,
27.685. It's 553,685.
Yep.
Okay. Yay.
And,
all right.
Oops. And then 9. On 9, I just looked at my notes. So when you have the width of the confidence interval, if the sample size is increased, then the width is also increased with the confidence interval. That's what I had in my notes, at least. Is that what you understood?
Yeah. Yep.
So that would be A, increase. And then on 10, if you have the confidence interval increase,
right, it should
to 99, then the width again should also increase. Is that what you understood?
Yeah, it says as the level of confidence increases, the width of the confidence interval increases. As the sample size increases, hold on. Are you sure about 9? Sample size increases, the width of the confidence interval decreases. So number 9 says what would happen to the width of the confidence interval if it increases sample size. So all it says here, sample size increases, the width of the confident interval decreases. So you sure 9's increase?
Did I have that wrong in my notes then? Let's see.
I think it's confusing because you write down the level of confidence increases, then the interval increases. But if you have the sample size increases, the width of the confidence interval decreases. So I think, yeah.
Did you find that in the reading somewhere?
It was on the video. It was, he had it on the video in print, and I stopped the video and copied it down exactly. So,
okay. I wonder if I just did that wrong then. Okay.
Well, you go by your notes because every time I guide it, so I feel like I get us wrong. So
no. Let's just see. Here, I'll go find and see if I can find it up here.
Yeah, see, I took it down as a note. Let me show you here what I wrote down. See if is that okay? The highlighted orange.
Okay. Yep. Okay. All right. I don't know why I wrote it down the other way.
Or you can go look at the video if you want. The video, I think it's I don't remember the first or second one. It's in there.
Okay.
And the homework, actually, if you look at the homework, it has a question like that in it too, right?
Yeah, I don't know. I thought I did that right too. I'm probably losing my brain. I just wanted to verify it on here too. Weird.
Also, maybe. Anyway, so whatever. I don't want to steer you wrong. That's just what I wrote down for the notes.
No. Down too, and I don't know why I wrote it down differently.
What was that?
What's that?
What was that noise?
I didn't hear anything.
It was like all of a sudden you open the car door, all this traffic sound.
Oh, really?
I don't know what's going on today.
I didn't hear it.
No.
Oh, I just wanted to find that. Okay, well, let's just go ahead. I mean, let's mark it with what your notes say, and then I'll make a note here.
Yeah, so for 10, if the sample size increased, I got decreased. And then for 10, I got increase, because if it's the width of the confidence interval has changed, if the confidence interval, the width of the confidence interval would increase if the level of confidence increases, the width of the confidence interval increases. Does that make sense for 10?
Yeah. Yep,
Okay.
that's what I put. Okay, and I changed the other one to decrease.
All right.
All right, 11. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know that the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. So what sample size do they need? So this is where we're solving for n number, but they have the margin of error.
Yep. So it'd be, the formula is n equals to the critical value times the standard deviation over m with the squared, right? That's the formula.
Yep.
Okay. So 90, so 95 would be the 1.96, right?
Uh-huh.
Times the 400 over, was 50 the margin of error?
Yeah.
Okay.
Squared.
Oh, I deserve so bad. Okay, so
No, sorry, it's probably disgusting. I keep sniffling over here.
no, I hear you. So I keep doing, like when I get the answer in the parentheses, I keep trying to do square root instead of square it. I don't know why I keep doing that.
Yeah. Well, it's
I'm like,
because we're
what is
learning so many
wrong with
different
me?
things.
I don't know. I just, my brain's stuck on wanting to square root everything. So are you getting 125.44?
No. I got 245.8624. Let me look at mine again.
So it's 400 divided by 50, right? Wait, do you square that first, or do you, yeah, or do you, and then you multiply by 1.96?
So I don't know. I have the critical.
My cat bit me. What are you doing?
Oh,
You bit my.
pay attention to me.
He wants to play. He just lay down.
I have
Sorry.
the critical value times the standard deviation, and then I divide it by. I don't know. Did I write that wrong?
Oh, you know what? I'm sorry. I don't know what was wrong with me today. I am just struggling today. So it's
No,
1.96 times 400 divided by the 50. I don't know.
and then squared it.
Yeah.
So round to the nearest whole number. So 246.
Did you hear what you just said? You said square root it. You said square root.
No, I meant square it. See, doing the same thing. That's funny. It's like, what? What did I say?
All right, I'm not getting this. All right, 1.96 times 400, right?
Divided by 50.
All right, okay. I don't know. I know how to do this stuff. I'm just like not feeling good.
Squared. Yeah, that's how I felt. Was it the last time? Was that when we were working with?
Oh my god.
And I was just like, okay, my brain. I can't do this.
God. Oh my gosh. So 245.862.
And then I just round 246 because it says to round it to the nearest whole number.
Okay. That's like my brain's not working today or something. I'm usually not like this.
Oh, I hear you. That's how I felt that last time.
I know, right?
I really did. Okay.
All right, so let me get my brain wrapped around something here. All right, let me read this one. I need to get my brain engaged. The mean salary of actuaries is mu equals 100,000, and the standard deviation is 36,730. You're interested to know the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of 0.05. And your formula, your hypothesis null, and then your alternative hypothesis. Okay. You collect a simple random sample of 36 women's salaries and find that X bar equals 111,000.
Share the permanent link. Share the permanent link. What does that mean? Oh.
Oh, are you there? Where did you go?
Oh, I don't know where I'm going.
I'm
I
talking,
just-
all of a sudden I hear this silence. I'm like, Emily.
I know. That's the same here. I don't know. It keeps disconnecting us.
Did you have to do
Alright.
anything different? I didn't do anything. I sat here and waited for you to pop back on.
No, it just showed, like, at first for a second it showed use this link to join or something weird, and then all of a sudden it went away and it showed you again down in the corner, and then it took a little bit to get connected again.
I don't know what to say. So I feel like I'm having some.
We're almost done. 3 more. Just hang in there.
All right. So this is the X bar minus the critical value times standard deviation over N for the lower limit, correct?
Yeah.
All right, so
yeah.
the X bar would be
11,000.
7,000.
Or excuse me, 111,000.
You're just you're repeating what I said because I'm messing you up. No, I'm kidding.
Minus the critical value, which was, are we doing, did it say?
95, well, it said 95%, didn't it?
Did it?
Question 12 says lower limit of this 95% confidence interval, which would be 1.9.
Oh,
Ow!
there.
Will you stop biting? He wants to play.
He's getting mad at you. Come on.
My husband's not home to hang out with, so don't you bite me again, T-Bone. You better stop it. Snotty cat. All right, 1.96
times
over times 36,730, right?
Yeah. Why does it have to be so mean and give us these ridiculous numbers? All right.
Because my brain's not working. It makes it that much more fun.
Divided by 30 or square root of 36.
Well, at least that's an even number. So,
right, so 6, right?
Yeah. So you're going to do 36,730, right?
Mm-hmm.
Divide by 6.
Yes.
Oh my God.
36,730 divided by 6. That's a fun number. Okay.
Wow.
Times 1.96. Going to get even funner. That's a little bit nicer looking though. And then we're going to subtract that from 0 minus 11. All right. So on my calculator, I got 1.553, whatever. Okay. So it wants us to round it to a whole number. So 99002. Is that what you got?
Yeah. Wow. That's the lower limit. Holy moly. Okay.
99002. That's so nice. Ugh, yuck. Okay.
That's crazy. Okay.
Now we'll do the upper one. So we got that other one figured out. We just have to go 111,000 plus that one. 122,999. What you got?
I didn't write down all those sixes. So you're doing the 99,001.53333 whatever plus 11,111,000, right? Is that what you're doing?
What am I doing? Yeah, right?
Yeah, we're taking the same on the right-hand formula, the 1.96 times the 36 divided by 36 squared. We're taking that same number, but we're going to add it to 111,000 instead of subtracting. Right?
What am I? Okay, I'm so confused for a second here.
Well,
yeah. So the 99002. What is that? Where does that go again? I'm sorry.
Well, it's the let's go back to the formula, the 1.96 times 36,730 divided by the square root of 36. That
Is
number,
that
that's the 99,001.533333. And then we add
okay?
that 99 number to 111,000 instead of subtracting it. We subtracted it last time, now we're adding it.
Thank you.
Does that make sense?
I write things down and I'm like, I don't know where that number came from.
Yeah, I do the same thing. But I didn't write down all those numbers, so I have to recalculate it because I don't have enough numbers in to give me the exact what I need. Yeah.
10, 2. 0, 0, 2.
That's-
2, 10,
yeah.
0, 0, 2. Okay.
Yep. Plus, let me just.
All right.
Crap. Wait. What am I doing? Got it. Right. So.
They are. All right. So for 14.
Oh, hold on. I'm sorry. I'm screwing up here. 1 point.
No,
Okay. Hold on. So 36,730 divided by 6 times, I forgot a step here, 1.96 plus, I'm getting a different answer now. What the heck? These numbers
okay.
are, okay, so you took 36,730 divided by the square root of 36, which is 6, right?
Yeah.
And then you took that number and multiplied it by 1.96?
Yes.
Maybe I did the first one wrong. So I'm getting 11,998.46666666, and if you add 111,000, I'm getting a different number.
Are you getting 122,999?
Oh, is that what you got? I thought you said 210.
I did because the first time I got 122,999, and then I went back and I plugged in that other one. I think that, yeah. So I think it's 122,999. Is that what you got this time?
Yeah. Are you
Okay.
sure that the other answer is right? Did I do this calculation right? The 99.
Let's do it. Let's do it again No, let's just do it real quick again. 36,730 divided by 6 times 1.96 111,000 minus at previous answer 99,001.5, which bumps it to 99,002. I think we're okay.
And we're subtracting or adding now? We're subtracting.
On 12, we're subtracting. On 13, we're adding.
Okay, yeah, okay. Woo, my brain's like, what? I know what I'm doing. My brain doesn't know what I'm doing.
You're fine.
All right. Good God. 14.
14. So the 3 requirements I have written down. Sample is simple random sample. That one. And then population standard deviation is known.
Yep.
So
All the
yeah.
above.
And then X bar is normally distributed. Yes. So all the above.
All right, I'm submitting mine. I'm just going to do it.
Okay, I'm going to wait just to make sure. And then if
100%.
Yay! Woo! Okay, thanks for saving me on that one.
Oh, thank you for saving me on those lots.
I had that written.
10. Dang.
I wrote that down wrong, so I'm glad that you caught that for me.
Yeah, I'm surprised my brain is working. Yeah, so I don't see you on the screen right now. I don't know what is going on with this thing.
You don't see me? I can hear you.
I can hear you.
Oh, I have my quiz up. I can take that off. There I am. Hi. I don't know if you can see me now.
I can see you in the bottom right corner, but yeah, I can't see anything else. That's okay. So,
all right. Good job.
Yep.
Woohoo.
Good job.
Do you have any questions? I got to change this on my thing. Thank you.
No, I just need to go back and review. But yeah, I understand the stuff. I don't feel great today, so it's kind of hard to. Math is one of those things where if you're feeling off, it really makes it harder to. I don't know.
Oh, I know. Because that's how I felt last That's how I felt last time.
We'll just take turns.
I know.
Oh wow, beautiful
So
sunset. Beautiful.
well,
I
was going to talk to you about that's cool. Yeah. I was going to talk to you about some other things too. I don't know if we want to stop the broadcast and then.
Yeah. Okay, let me stop the broadcast. But we got 100
Okay.
in the quiz. Hopefully, the other video I can post both of them. So let me. All right. Good night, Emily. Thank you. I'll stay on.
I'll call you. Or once we stop, can we just stay on? I don't know. Okay.
I don't know. I'll see. All right. Bye.
Okay.